Welcome, everybody, and thank you for joining us today. My name is Katie, and I'm the Director of Business Development at DoubleRadius. As always, the goal of our presentation today is to give you the tools to build a better network. And with that being said, we're excited to have American Tower present today on the topic of building the towers that you need. Making the presentation today is Doug Schmidt, President and Principal at American Tower. Since Doug purchased the company in 2002, it has become one of the leading tower manufacturers, specializing in high quality, easy to assemble towers with the shortest lead times in the industry. Under Doug's leadership, American Tower's product line has expanded to include the Amerite 25, 45, and 55 series towers, the self-supporting Wi-Fi series towers specifically designed for Wi-Fi users. Before we jump into the presentation, a couple important things to mention. First, as you have any questions, please make sure to enter them real time in the questions box. Don't wait till the Q&A session at the end. We'll be picking a winner from those who enter a question before the Q&A session starts. That winner will receive a DoubleRadius and American Tower swag pack with some really cool items. Second, after the webinar, a survey will pop up on your screen. Please take a minute for that, as we really appreciate your feedback. And with that, I'll hand it over to Doug to get us started. Doug, why don't you take us away?
Thank you, folks, and thank you, DoubleRadius, for allowing us to present to the group of people here online. Thank you all for spending the next 45 minutes or so with us to learn a little bit about building the right towers that you need. And I'd like to start off and tell you a little bit about American Tower. First, we've been manufacturing towers since 1953. We're 100% American-owned, operated here in the USA. We're located in Shelby, Ohio. Shelby is halfway between Cleveland and Columbus, Ohio, in the northern part of Ohio. And you say, why are we located in Shelby, Ohio? It's the home of seamless welded tubing. Yes, in little Shelby, Ohio, the seamless welded tubing was invented that we all use today in our tower application, with the largest manufacturer here in Shelby being ArcelorMittal. We manufacture self-supporting and guide towers. Our markets include the residential, the Wi-Fi, the utilities, telecommunications, public safety, military, oil and gas, etc. Our primary market is under 300 feet. We have never abandoned that marketplace. We still manufacture today residential television tower for those people that are grabbing the over-the-air public television. We sell also to this type of application, the Wi-Fi residential and small business application tower, all the way up to public safety and telecommunication people, which includes the Wi-Fi people. Primarily what we find in the Wi-Fi business is the applications for larger self-supporting tower typically run between 100 feet and 190 feet. And everybody always asks, well, why does it stop at 190? Because when you hit 200, you run into FAA requirements, lighting requirements, and painting requirements. So that's kind of the marketplace that we focus on here at American Tower. We've been doing it for a very long time, as you can tell. We pride ourselves in higher quality, easier to assemble towers, which saves you a lot of time in the field from an assembly and labor standpoint.
All right, let's take a quick poll here. Take about 15 seconds to complete this. Question is, your applications for towers include? And if you could check the options that apply, that'd be great. Looks like as far as applications for towers, we've got about 57% using towers for residential, 81% for commercial, 14% used for video, 14% for solar, and 24% for other.
Well, that kind of leads me to believe we had a lot of WISP people on here using smaller towers for, I guess you'd say, the residential and small business people to catch the Wi-Fi signal. And then it sounds like there's a good portion of people that are using the big central towers for broadcasting of the broadband. I think since the title of this seminar is choosing the right tower, I'd like to go through the major topics that everyone needs to know before they purchase the tower, because I always say we want to sell you the correct tower for your application or the right tower for the job. So the most important question that we have are these first four here. One, what is the application? In other words, is it for Wi-Fi? Is it for your backhaul? Exactly what are you using it for? That starts the process, so we have an idea of what to start to look at your tower. The second thing is what's going on the tower. The antennas, how many, what heights. You may have several antennas at the same height. You may be spreading them out over the height of the tower. Or it may be just one single antenna to catch Wi-Fi for a customer. Or if it's a SCADA application, or if it's a camera application, again, where are they going to be located? How many? And most importantly, if you have the spec sheets of the antennas and what's going on the tower, that'd be a great help. Most manufacturers do have wind loading as part of their spec sheets. That helps us narrow down the choices for you of the tower. And of course, number 3 there, what heights are you looking for? We can help you, but also if you've done maybe some drone surveys or have some other analytics done, height requirements are also very important. The location of the tower is the next most important area we need to look at, the geographic area and what space is required. The geographic area is very, very important from the standpoint of wind loading. For example, if this is going into Florida, their wind loading today in most counties is at 130 miles per hour. If you go to most of the inland parts of the country, it's typically at 90 miles an hour, and that's a significant difference. Occasionally, you'll run into some special requirements on the geographic area. For example, we just did a series of 8 towers in Oregon, and they had 2 special requirements in this county. One is for seismic, better known as earthquakes, and number 2 is they had additional wind shear requirements because of the mountainous area of the county. They deal with a lot of different wind shears. So therefore, there was a lot of different requirements for the tower that was installed. Another reason we need to know some of the location information is the type of soil. For example, if you're putting this into Mississippi, you may have a very soft soil condition versus putting it up in Colorado where you may be putting it on top of rock. That also helps us determine which tower is best for your application, the type of base, and of course the net result of all these metrics are the cost of the tower and the style of tower. Additionally, you need to look at your local codes. Local codes are each county has a set of codes that they follow. And it typically starts with an EIA, TIA specification. Most counties today are following 222H. 222G is the older code, and some counties are still following G and have not upgraded to H. Most of the time, if you pass G, you will pass H. G, the older code, was a little bit more strict required a little additional wind requirements and loading requirements. So typically, if you have a G tower, it will, in most cases, pass H. H is kind of a little step back from G. They kind of, when they proposed G a few years ago, they took a big step from the previous set of specs. And they found later, after many installations under G, they went a little bit too far, and that's why they've stepped back to H. So most of the towers today are all spec'd at H, which leads to number 6 here is a PE stamp required for your location. Again, going back to 1, 2, 3, and 4 we just talked about, the location of the tower is very important to know. The PE stamp is going to be required for most commercial tower installations that are transmitting signals. Most counties today have adapted that a PE stamp is probably not required if you're receiving signals and on private property. But once you transmit a signal, it's called a commercial tower, and most county governments will require a PE stamp for that tower. That's not true of every location, but a great majority of the counties do require it, especially in the larger, higher populations, communities that are more developed with their building codes. So it's very important to check with your local county and your county requirements before purchasing the tower, because a PE stamp may change some of the requirements on the foundation or some of the tower requirements for that tower based on county conditions. So I think it's pretty important that you investigate that up front before you call the tower people to ask about a price of the tower or the type of tower. The next thing you need to know is there any special requirements that you folks may need? For example, does it have to have an anti-climb because it's in a neighborhood where you don't want kids climbing it? Do you have poor soil conditions, much like I mentioned about Mississippi or even in Colorado? You may have extreme soil conditions. We have put a radar tower on top of a mountain in Colorado, and they actually drilled into the rock to put the foundation in. So those are the things that are important to know up front. Also, are you planning to put other tenants on the tower? I realize today that a lot of people would love to have another tenant on the tower and get a monthly rent for installing a tower. This is something that we need to know up front to give you a little bit of a cushion on the type of tower, the size of the tower, the construction of the tower, so that you have an opportunity to put another tenant on it for a revenue stream on these towers that you're putting up. Lighting, that's one of the things that is optional, you know, from the standpoint of looking at it from a safety standpoint. Grounding or additional grounding, depending on the type of equipment you may put it on it. And then obviously the FAA painting requirement, you'll have to find from your local area where you're putting up this tower, if you're any flight paths for airports, hospitals, helipads, or public areas where they may have landings of vehicles for safety, police, hospitals, etc. That would require some type of FAA painting for protection of the pilots and the planes.
All right, let's take a minute to do our second poll here. Question is, what best describes your experience with towers? If we can take about 15 seconds again for this one. So again, the question was, what best describes your experience with towers? We had about a third of folks, 32%, say we easily find what we need whenever we need it. 26% said they sometimes settle for less than an ideal tower solution.
I'd like to make a response on that number 2 answer there, Chad, about people not getting satisfied with the type of tower that they're getting. I think if we go back to these 4 questions, you know, what the application is, what's going on the tower, what height is required, the location, and then of course following this up with codes and any special requirements. I would like to stress these bullet points here of 1 through 7 for those that settled for a lesser tower than they thought they really wanted or really needed. This is a major, I guess, shortfalling in our industry today, where we're not quite getting the towers we need because we don't always have the information, as I outlined here, available to the tower people, i.e. American Tower or any of my competitors. Given this information, we should be able to help you get the right tower for the right application. I do know that today, with many of the WISP people being under the pressure of some of the federal money and the funds that have come available, the CAF money, I realize that there's a lot of deadlines, a lot of build out times that were made and promised in the grants that were applied for, and some of these monies that were received by many of the WISP people. They are buying towers today just to put up a tower, and sometimes they are not buying the right tower. I know that's happened to several of our customers before they got hooked up with us, is that they weren't buying 100% of what they really needed. I think there's been a proposal put in front of the FAA, actually the FTC and the USDA and other federal agencies that have granted this monies to kind of put a little hold on the closing dates. You may want to contact your person or your group that you got your money from and ask them for a little breathing room on the completion of your WISP. That's one of the areas that I hope does not get people in trouble when they put up too much loading on these towers and we get a good storm. I hope that there's enough fudge in the engineering of the tower to keep it going for you guys. I don't want to see anybody fail. My purpose in business is always try to make other people successful. And so when we do a job, we try to do it right, and we don't want any towers coming down. The types of towers that are out there to choose from, that are out there in the marketplace, the 3 major ones are self-supporting. Some people also call these lattice tower or freestanding tower. Guide towers, which are supported by wire cables. And then there's bracketed towers, which are towers that are attached to a building or a structure with a bracket. So it's kind of self-explanatory. And when we're looking at a self-supporting tower, now this tower here that's going up, the reason why I put this one, we've all seen many pictures of completed tower, but we may not have all seen the type of equipment that's required to put up some of these larger towers. This one, this self-supporting, is a 180 footer for a WISP down in Mississippi. And if you notice, he has a pretty decent foundation underneath that tower because he was in softer soil condition. He was a very smart WISP and hired the right type of crane to put up this 180 footer. Now he's only, what you see here, he has just around 100 feet. He still has another 60 feet, excuse me, 120 feet. He has another 60 feet to still go up. So he had the right size crane, the right equipment. He had a nice clear area to work from. This is a great installation, great equipment, a great WISP guy. And by the way, fellas, this is the first time this gentleman ever put up a self-supporting tower. And quite honestly, he's ordered his second and his third from us already. A guide tower, this is a pretty simple one, but it kind of, the reason why I put this guide tower up is, one is you can put a guide tower close to a building. You don't need 100% free clear space. If you have the right location and plan it out, you can put a guide tower close to a building. The other reason why I put this picture up is to give you an idea of how far, when you're sitting at the guy location to the tower, the cabling is. The rule of thumb, it's 70% from the guy height to the guy anchor. So this one gives you an idea of, if you're up X number of feet, if you're 100 foot in the air, your guy contact set base. So this gentleman here that put this one up, this is for a WISP application that happens to be a building of a WISP guy, and this is one of his central towers for his WISP application. And he did a good job at, I guess you'd say, putting it as close as possible to his building and not having the obstruction of his guys. This is our AME 55 here, which is a pretty stout tower and very commonly used in the WISP applications. A bracketed tower, typically you find bracketed towers on residential or small business applications where you're putting a smaller tower that cannot be completely freestanding on its own, but to give it additional support. This tower here is bracketed, as you notice here, on the eave of the house. Above it, he obviously has his WISP antenna. And above it, guys, is a good way to get an additional revenue stream for any of you WISP or tower guys, putting an over-the-air antenna with a rotor as a side business to the WISP people. Yes, people still today like to see over-the-air television. And if you are looking for some additional revenue stream, this is a great example of one of our customers that is not only selling WISP services, he's selling the services of installing over-the-air television and radio reception to help improve his customer satisfaction. Now, if you notice this tower here, it is what we call our step series. It is a tubular rung tower, which makes it very easy to climb, very easy to service, very easy to handle, and quite honestly, it's a very competitively priced 12-inch face tower. In other words, the distance of the tubing is 12 inches. But this is ideal for end-use WISP applications for residential and small businesses. It's a great tower to consider for your end-use people. But again, going back, self-supporting, typically we specialize in this up to 300 feet. We stay under 300 feet. We don't want to compete with the carrier base. This is the most common tower used today for any central or major tower end because of the lack of real estate needed. You can have a very small footprint for a very tall tower. But by far, this is the #1 selling type tower for WISP and police, fire, public utilities, carriers, etc. Again, small footprint, very little real estate needed. The difference between a self-support and a guide tower is you need a lot more real estate. However, the cost of the tower for the height is significantly less, but you need a lot more real estate. So example, if we went up 100 foot with a guide tower, the radius of your circle or underneath that tower would be a minimum of 70 feet. So if you went to 200 feet, just take the 70-foot rule, you're basically going to 140 feet. So you need a lot of real estate for a guide tower, but the cost of the tower for the height is much cheaper. It's a very competitively priced tower as compared to a self-supporting. Reason, a lot more steel is the biggest thing. Also the base and the foundation. You have a lot more yards of concrete in the self-supporting tower. You have a lot more infrastructure as a result. When you're talking about a, I guess you'd say, residential tower, 10-foot sections are in the low $100 per 10-foot section price. They're very competitively priced. Ideal for lighter duty, WISP applications, TV applications. I noted that we had a couple camera people that were on this. Ideal for camera operations, surveillance. Typically what we see cameras that go on universities, we typically see camera towers anywhere between 10 feet and 70 feet. I'm assuming most of the camera people that are on today are somewhere in that neck of the woods. If you travel Purdue University, Ashland, Notre Dame, Penn State, Ohio State, North Carolina, University of Georgia, et cetera, you'll see our towers located on many of these campuses for camera operations. We also, as a side note, we can powder coat our tower for an additional color. We have done towers in green to match trees and foliage. We have done towers in school colors. We just mentioned universities and schools. We've done other colors for other applications. Another popular color is a flat matte black, due to the fact that the flat matte black doesn't reflect and it hides well in different locations. Some of the reasons why you may want to consider using American Tower over my competitors. Number one is we give personal and professional help to anybody that calls in and talks business with us. We feel we have some of the best people in the business to talk to about assisting all of you folks to get the right tower. We carry many pre-engineered tower designs. We try to keep most of these in stock. Today, because of the fast growth in the industry, especially with WISP, our inventories are down to the lowest they've been in years. Our typical turnaround time for manufacturing of tower, if we have to make it from scratch, minimum is about 4 weeks. Our maximum right now is about 8 weeks. So if you're looking for a quicker turnaround, please feel free to give us a call. We can supply tower on a very timely basis today. We are some of the fastest towers to install. We design our tower that way. We try to keep all of our fasteners from top to bottom on our self-supporting tower the same, so that you don't have 6 different sizes of fasteners from top to bottom. We try to make everything as uniform as possible from top to bottom to help speed the installation. We feel that that cuts down the amount of time to the field, which keeps your costs down to a minimum. So this is a big labor savings to you folks in the field. Additionally, all of our tower sections are inspected and prepared for installation here at the factory. We clean all the bolt holes after galvanizing, and the sections are also cleaned to make sure that the sections slide together and fit together well. I think if any of you folks have put up tower, you will know the struggles of a tower that is not clean and the bolt holes are filled with galvanizing. This can be a real hassle in the field because then you need to have the right size drills, the right size reamers, file, cleaning equipment, reamers, brushes, gouges, whatever, to try to clean the tower up before it goes together. All of our tower is inspected and cleaned here. Typically, we have I guess, a vast amount of experiences with many of the WISP people that are putting up these towers as quickly as they can for their customers. We have a WISP down in Texas that he went from putting up 3 towers a day to putting up almost 5 towers a day because of the ease of the installation without having to clean up the messes in the field. One of the other things that we do is we clean off all the galvanized icicles that are found on the towers after galvanizing. We have heard of many people getting cut or even stabbed with the galvanized icicles. We clean those up before it goes to the field. We have felt that that is always a Workmans Comp problem for professional tower installers, with their installers getting hurt in the field by the galvanizing. We have almost virtually eliminated any of those hassles in the field. We also have very short lead times. As I mentioned, we try to carry a share of tower in stock of various pre-engineered tower. Custom towers, we're looking at 4 to 8 weeks for manufacturing, which again, I know is very attractive to people in the marketplace. We have adjusted our labor and our materials to meet the customer demands over the last 2 years of this growth in the industry, and we've been able to keep up with it. And of course, the last reason why I think you should buy from American Tower, we're just darn great people. And we're good Midwestern folk here in Ohio, and we try to treat people like we like to be treated. So we love to hear from any of you folks. DoubleRadius here is a distributor of ours. They have some great salespeople. They have put together a tower team to help assist all you folks that are customers of DoubleRadius. If they cannot help you, we have a great working relationship. We can help you folks step by step to get the right tower, and therefore obviously the right price for your application. We can help you get the PE stamps. We can help you design. We can help you with your special shipping needs to your locations, for example. We have some unique trucking companies here that can deliver to job sites if necessary. DoubleRadius has also made arrangements with us to help expedite shipments. We will drop ship directly from us to you, the customer, to help expedite shipping. So in other words, it doesn't have to go to DoubleRadius and they reship it to you. We have an agreement with them to ship tower direct, which will help expedite any of these installations. So I guess I'll leave it to anybody here if you have any questions, if you have any comments, if you have any specific hassles that you'd like to speak about or problems, feel free to ask. This is the time.
Yep, thanks, Doug. We actually do have a few questions that came in through during your presentation. So I will start with the first one. So the question was, do you ever design or manufacture towers over 300 feet, for example, 100 to 110 meters?
Yeah, we do. And at any time you run into that height of tower, that's a pretty good engineered tower. And we do have engineers that put this together for you. Our primary focus has always been under 300 feet, but over 300 feet, we do engineer, we do manufacture towers to that height. And we're more than happy to speak to anybody regarding their specific application. So the answer is yes. We do manufacture over 300 feet. That's not our primary marketplace. A lot of times when you get over 300 feet, you start running into carrier grades and other things, and we just don't compete in the marketplace.
And then another question regarding 300 feet is, I've heard that there are upcoming changes to the 300-foot rule. Is that true?
Yes. Yes. A lot of the, I guess you'd say, depending on the city and the state, the county, the area of the country, I know that California has gone crazy over heights. Okay. They're calling it site, what do they call it? Site problems. You know, people can't see the ocean, you know. So there are some areas like California. I know that Florida is also considering some height restrictions as well. I guess they don't want to see 500-foot, 300-foot towers because it's a very flat environment, and they just don't want to see these monster towers up, especially at those heights. When you get up that high, they typically have to have beacons during the day and red lights at the night. And I guess there's been enough complaints by communities that are trying to restrict it. Also, because of some of the requirements for wind and loadings, some of the communities have gotten fear about tower heights and tower disasters, and there has been some talks in some of the communities about doing that. However, this is, from what I understand, this is more of a location issue than it is a manufacturing or an industry problem. It's more a locality issue. That's what I've heard. There may be other ones I'm not aware of, but those are the ones that I am aware of.
No, great. Another question, does American Tower manufacture self-supporting towers without tubular legs?
Well, I'm assuming they were talking about a solid rod or a solid leg one, okay? And yes, we do convert to solid rod from tubular. However, with the cost of steel today, which has basically doubled over the last year, the cost of a solid rod or a solid leg tower has gone up tremendously. So a lot of people have taken a step back because of cost to go back to tubular. The advantages and disadvantages are really specific. When you're looking at solid leg, you don't get internal corrosion. So if you have a very tall tower, where you have actually different weather conditions at the top and the bottom in cases, you get a lot more condensation on those type of towers. And a solid rod tower does not prematurely rust interior wise as quickly, because there is no interior, obviously. So there's a lot of people going back to, I guess you'd say, tubular because of the cost of steel today. But yes, we do solid rod, or if you want to call it solid leg towers.
Okay, great. And then another question that just came in, what federal rules do we need to comply with for unlicensed versus CBRS, PAL, GAA, like section 106? I'm sorry, I don't know this one. NEPA, NEPA. Will small cell rules help? I'm not sure if this relates to towers in any way.
And please say the question again. I kind of missed some of it, so can you try it again?
Okay. Yeah, it says, what federal rules do we need to comply with for unlicensed versus CBRS, PAL, and the GAA, like section 106, NEPA, NEPA, I don't know that term. And then will small cell rules help? I'm not sure if this might not have, be related to towers.
A lot of it's related to the signal more so than the tower, okay? But I will tell you, I'm picking up, I guess you would say, the problems with signals, I think is what this gentleman is referring to. You got to be very careful with how your antennas are pointed today, because with the FCC, you can't have your antennas pointed toward commercial radars. There has been in Ohio here, for example, at least 4 cases of some of these signals being pointed to commercial airport control areas and causing problems and interference. I think this is what this gentleman is referring to. But when it comes to the tower, the only problem with tower is not related to the signal, but when it comes to the FAA is tower heights and if it needs to be lighted or not, which I talked during my presentation a little bit about. But what this gentleman's talking about, I believe, is regarding his signals and I guess you'd say the FCC requirements and the use of these certain bands of signals. It can interfere with other operations with airports, radar, and other communications. So if they find, like they did here in Ohio, with the 4 towers that were overlapping some of the aircraft control, which one of them happened to be at Wright-Patterson Air Force Base, one of their control towers, and the other one was at the Cleveland Control Center, which is the main control center between Chicago and New York. They had to find the WISP person that put up the system and have them redirect their antenna so they didn't interfere with the aircraft and the radar. So I hope I answered that gentleman's question. I may not have, but if he could pop us an email through you, Katie, I can maybe try to help him a little bit more with that, with some other information after this session.
Yep, I will do that. And I will ask you one other question while we're waiting. Is American Tower able to build a 199-foot self-supporter with 150-mile-per-hour wind speed?
Yes, that would be an engineered tower. Most of the tower that we have in stock today is up to 130. But again, if we run into some of these high wind applications for coastal areas or high mountain areas with great wind shears, we have done a 150 before. The difference in the tower versus, I guess you would say, what you would find on the shelf is the amount of steel, for a lack of a better word. In other words, it's heavier legs, heavier cross members. But can we get him a tower that meets and exceeds 150? The answer is yes. What I would need to know from him, going back to my little outline at the beginning, is what is he putting on it, at what heights, what type of equipment, etc. And yes, we can do this. And being at 199, I guess he's trying to stay underneath the 200 magic number for the FAA requirements. I would always say go 195, don't go 199, because somebody from the FAA that went out there with the site may measure 200 and not 199, and we'd be in trouble. So I always say go 5 feet under, or 10 feet under, be on the safe side. But yeah, we could do that for the guy. And yes, we have done a 150, and one of the ones we did was on the West Coast in a mountainous region with extremely high wind shears. And it was for a WISP, by the way. So yes, we can do that for you.
Okay, great. Well, Doug, I think we can circle back after this with the gentleman from the previous question, but I think with that, I think that's the last of our questions. If there's any more that come in, we can follow up via email. So, I just want to say thank you to American Tower. Thanks, Doug, for, helping, go through the tower options for us. And if, next time, if there's a need, we really please utilize American Tower and, come to DoubleRadius and we can help you working with them, pick the tower that you need to help with your deployment. And then as we close out, there's going to be a quick survey at the end that'll pop up on your screen. Please fill that out. That'll help us for the next webinar. Thank you again, and we'll see you next time. Thank you, Doug, for the presentation. It was great.
Well, I want to thank everybody at DoubleRadius. I mean, it's a great company. It's a great distributor of products out there, and you know, the whole group there has been fantastic. And I know that most of the customers I've talked to at DoubleRadius, they seem very knowledgeable about their business, and looking forward to work with everybody there.
We are as well. Thank you, Doug. Have a great day, everyone.